So let's talk about AI. I mean, generative AI is everywhere right now, and its appetite for computing power, it's just insatiable. This whole boom is pushing our tech right to the absolute edge. But what if the next great leap forward doesn't come from building something bigger? What if it's about fixing something incredibly small, something that's just been wasted?
Right? How does a single wasted bit unlock massive AI power? That's the puzzle we're going to solve today. We're going to uncover how this one seemingly useless piece of data became the secret weapon in the race for AI dominance. Stick with me, this is a good one.
Okay, to really get why this matters, we have to go inside the engine room of the whole AI revolution, the data center. I mean, these places are under just tremendous pressure. Think about it. Training and running these huge AI models, it creates staggering costs and pushes their physical capacity right to the breaking point. The demand is simple and it's urgent. More power, more efficiency, and they need it yesterday.
And the scale of this? It's honestly mind-boggling. We're talking about the market for these specialized AI chips, the accelerators. It's projected to just explode to over $500 billion by 2028. That's not just a technical challenge, folks. That is one of the biggest economic opportunities in tech, period.
So, the big question is, how are companies responding to this? Well, let's look at one of the heavy hitters, AMD, and their brand new answer to this whole challenge, the Instinct MI350 series.
And here it is. This is the AMD Instinct MI350X platform. Now, this thing wasn't just, adapted for AI. Nope. It was built from the ground up specifically for the insane demands of generative AI. It's basically designed to be an absolute monster of performance.
Now, this is cool. We get to kind of peel back the layers here. On the left, you've got the whole package, right? The GPU, the cooling solution, the whole shebang. But then on the right, we're zooming way in, right down to the heart of the machine, the actual silicon die. And it's down at this microscopic level, folks, where the real magic is happening.
Okay, before we get to the secret sauce, let's just take a second to appreciate the raw power we're talking about. It's built on their new CDNA4 architecture. It's got a colossal 288 gigabytes of super-fast memory, and get this, it can hit a peak memory bandwidth of 8 terabytes per second. You know what that means? A single one of these GPUs can handle an AI model with over 500 billion parameters. And parameters, that's just the internal dials and knobs the model uses to think. It's an absolute beast.
But brute force isn't the whole story, not even close. The real breakthrough, the thing that gives this hardware its edge, comes from being smarter, more efficient. It's all about finding a way to make the data itself smaller.
And the name for this technique? It's called quantization. Now, the easiest way to wrap your head around this is to think about a photo. You take this huge, beautiful, high-resolution photo, and then you compress it into a JPEG. You lose a tiny bit of that perfect detail, right? But the file becomes way, way smaller and faster to send. Well, quantization does the same thing for AI models. It reduces the precision of the numbers, which makes the whole model smaller, faster, and way more energy efficient. But of course, there's a catch. There's always a trade-off, right? If you use a high-precision format like FP16 or 16-bit, it's super accurate, but it's also big and slow. If you drop all the way down to a low-precision 4-bit format or FP4, yeah, it's way smaller and faster, but you risk squishing the data so much that you lose critical info, and the model just breaks. It stops being accurate. And this is the fundamental problem everyone in the industry is trying to solve.
And this, my friends, brings us to the absolute core of our story. A brilliant, almost unbelievable hack that tackles this precision problem head-on by taking advantage of a very strange quirk in how computers handle numbers.
So here's a weird little computer science fact for you. In the standard way computers represent numbers, there isn't just one zero. Nope. Because of how the positive or negative sign is stored separately from the actual number, you actually end up with two of them.
You have a positive zero and a negative zero. And for pretty much every calculation, they act exactly the same, which means one of them is totally redundant. It's just wasted space. Now look, in a big 16-bit number, who cares? It's a drop in the ocean. But in a tiny 4-bit number, that single wasted value is over 6% of all the numbers you can possibly represent. That is a huge loss of precision.
And this is where some researchers at Cornell University had an absolutely brilliant idea, one that AMD has now put into their chips. They asked, what if we could reclaim that wasted space? And as they put it in their paper, they figured out how to remap the redundant 0 into a new, totally useful special value. Just that one simple change dramatically cuts down on the errors you get from quantization.
And this graph just shows you perfectly how it works. That colored blob, that's the shape of the data inside an AI model. The standard formats, they struggle to fit that shape perfectly, and that creates errors. But by adding that one extra special value right in a strategic spot where -0 used to be, the new format can hug the curve of the data way more closely. And boom, the error just plummets. Okay, so we've gone from the huge data center all the way down to a single wasted bit. Pretty cool, right? Now, let's zoom all the way back out and see what this tiny, microscopic hack actually means for performance at a massive scale.
And the results are, well, they're dramatic. Because this whole -0 trick makes the super efficient FP4 data format accurate enough to actually use, the new MI350 series gets up to a 4 times increase in throughput compared to the last generation. A 4x jump! That is a massive, massive leap in just one product cycle.
Okay, but what about the competition? How does it stack up head-to-head? Well, according to AMD's own benchmarks on the huge Llama 3.1 model, the MI350 platform delivers up to 1.3 times the inference speed of NVIDIA's flagship B200 when they're both using this new FP4 format. That's a serious claim. And it's not just about raw speed. For these enormous AI models we have today, memory is king. And on that front, the MI350 series has a really big advantage, offering way more of that high-speed memory than its direct competitors. And what that lets you do is run bigger models on fewer GPUs, which makes everything simpler and, you guessed it, cheaper. And look, at the end of the day, for the companies running these massive data centers, it all comes down to the bottom line. And this combination of raw performance and clever efficiency, it translates directly into better value. AMD's claiming up to 40% more AI tokens, basically more AI work, per dollar than the competition. All right, so let's just quickly recap the whole story. The insane growth of AI is forcing hardware makers to be smarter, not just stronger. AMD's new MI350 series does exactly that by using these super efficient low-precision data formats. The secret sauce? A clever trick that reclaims the wasted -0 to make those formats super accurate. And that one tiny innovation unlocks massive gains in performance, memory, and cost. It's just such a powerful reminder, isn't it? That sometimes the biggest breakthroughs come from the smallest, most unexpected places. And it really leaves us with a fascinating question to think about. As AI models keep growing exponentially, what other wasted bits, what other hidden computational resources are just lurking in our systems, waiting to be discovered and become the key to our next giant leap forward?